All right. All right, guys, I'll get started. I will begin with a word of prayer. Ahem. 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 I can't whistle, so that's all I got. I'll pray. Heavenly Father, we thank you for this day. Again, Lord, I thank you for these students. I just pray that you be with us today. Help us to glorify you, Lord, in what we do. In your name I pray, Lord Jesus. Amen. Amen. So first things first. Here is a little something. Take one and... It's not a quiz. Relax. So take one and pass it over. I hope I've got enough for everybody. And hand these to the back row. Hopefully they... Yeah. So, you know, you guys asked me about the inequality problem yesterday, which is fine. And I just was like missing a sentence, basically, from what I said. And that missing sentence corrupted my thinking into thinking that I was so far away from the solution that it was hopeless. And that's wrong. I was really, really close. So the basic idea is this, guys. If we have f prime of x is less than 0, all right, for, you know, a less than or equal to x less than or equal to b, and then if you have if you have, let's say, you know, c1 less than c2, right? In let's suppose you have a less than or equal to c1 less than or equal to c2 in b. So in other words, what I'm trying to say is, suppose c1 and c2 are in the interval where you know that the derivative is negative. What does that mean? Then essentially we have the following. c1 less than or equal to c2 implies that f of c1 is greater than or equal to f of c2. This is what it means for a function to decrease, right? So, I mean, the derivative being negative means that we get an inequality in a particular order. Likewise, if we have the derivative is positive, same song and dance, then, you know, c1 less than or equal to c2 would imply what? It would imply f of c1 is less than or equal to f of c2. So another way to say this is increasing functions preserve inequalities, decreasing functions reverse inequalities. Okay? So what I just handed out to you guys is a proof. I mean, just a short calculation. If we define g of x equal to inverse tangent of x, so you know we have g of x is equal to inverse tangent of x minus x. And I show that g prime, I won't go through the calculation, but g prime of x is minus x squared over 1 plus x squared. Well, that's clearly less than 0 for x greater than 0, right? So that means that g is decreasing from 0 to infinity. What's that mean? That means, of course, 0 less than x, right? For x positive. So that implies that g of 0 is less than g of x. But that, what does that mean? What's g of 0? This is 0. Inverse tangent of 0, 0, right, is less than tangent inverse of x minus x, which is to say that x is less than inverse tangent of x, which of course we can flip around to say that tangent inverse of x is smaller than x. I just flipped that around, didn't I? Oh, I think I can fix it quickly though. Check it out. That's supposed to be greater than, because it's decreasing. Greater than, because it's, you know, same. Greater than, and that one's fine. Now that's half of what we're asked to prove in that problem. And I give you the other argument at the bottom of the page to prove the other inequality. This is what I was trying to tell you guys. Find a function, show it's decreasing that or increasing, that gives you an appropriate inequality and allows you to establish such things. You can use the calculus 1 that you know to do these things. The other strategy, of course, is just to try to like brute force come up with an inequality using algebra. I'm usually less successful with that. It depends on the problem, though, you know. Okay. Anyway, enough. I wanted to revisit that because I felt like I didn't quite do it justice yesterday, and there's no need for that. So anyway, all right. So guys, you have homework questions, I'm guessing? No? Cool. Well, I will work some problems then. I learned my lesson. I'm not going to make up partial fractions problems. I'm going to look them up in the book and work them. That's why I carried this monstrous beast of a book up here. So let's work some examples. So today's topic, of course, is partial fractions. Lots and lots. Bless you, yes. Work number 9. Seems like a good one to work. If I accidentally do any of your homework problems, my apologies. Not intentional. Oh, I don't need to apologize for that? It's encouraged? Yeah. I can't take the test for you, though. Let's see here. I haven't reached that level of customer service yet. Let's see here. What if I get paid? Yeah. There are schools like that. Yeah. What? Oh, no. No, that was not a, yeah, okay, I got it. Okay, so this is our goal. We want to calculate this. So the strategy is as follows. Convert integrand to sum of basic rational functions via the partial fractal decomposition. All right. So what do I got here? I got myself an x squared plus 12x plus 12. And I'm going to go ahead and factor the denominator if you guys don't mind. I'm going to trust but verify the cameraman's work. This is Isaac. Isaac is 6. He's hanging out with me today. Isaac, what's your favorite cartoon? Naruto. That's right. Let's see here. So we've got x times x squared minus 4, right? Oh, we can do better than this. Let me just, if you allow me to erase this, I see what I should write. What should I write? Yeah, let me just get to it. Okay. So something that's implicit within what I said yesterday, but I didn't emphasize yet, is that the partial fractions decomposition has nothing, almost nothing to do with the numerator. There's one caveat to that, which is that if the numerator is the same degree or larger than the denominator, then you need to do something before you do partial fractions, because there could be a polynomial piece. Hmm? That's true. Okay. Yeah, okay. Yes. So let me try to phrase it more carefully. The setup of the partial fractions doesn't depend on the numerator. The values of a, b, and c totally dictated by the numerator. I agree. But this step right here, I could make this whatever I want, a quadratic, any other quadratic, and it wouldn't change that a bit. Okay? Anyway, so now we multiply by the denominator, both sides. So that's a times x minus 2 times x plus 2 plus b x times x plus 2 plus c x times x minus 2. It's always whatever you don't have there that remains when you multiply, right? Everything cancels except for what's there. Does that make sense? Please don't try to memorize this. Like, think through it, you know? Okay, so x equals 2. We have, I mean, x equal to 0. How about that one? What's that give us?
Does it matter if it's x minus 2 before the x plus 2 or x plus 2 before x minus 4? So that will change the relations.
I mean, we could change the meaning of a, b, and c by relabeling, right? I mean, your a and my b might be different if we put, I'm not sure which thing you're talking about. If you're talking about this multiplication or if you're talking about this sum up here. Like I could, okay. I mean, I could just as well have been like c, b, a, but.
I'm wondering though if the x minus 2 has to come before the x plus 2.
Oh, well, no, I mean, this is the addition of function. It commutes, yeah. Uh-huh. You know, we go to great lengths to divorce you guys of thinking of things as not commuting, and then you come take linear algebra, and then all of a sudden they're like, hey, matrices don't commute, and you're like, what? Because we've like taught you everything commutes. So we're like setting you up for linear algebra when finally you come into contact with things that don't commute. So it's our conspiracy as math teachers. Very successful. So these are both 0, and that's what? Minus 4a, yeah? So therefore, a is what? A is equal to minus 3. X equals to 2, what's that give us? 4 plus 24 plus 12 is equal to, I guess I can do that. What's that? Isaac? Yeah, what's this? 4 plus 24 plus 12. Don't remember. What's 24 plus 12? I don't know what that means, but I better check on it. Hey, stop that. No one wants to see me. What are you doing? All right, you booger. This is probably a bad day to miss. Let's see, we got what? 36. I think that's 40, isn't it? So 40. And let's see here, 2. That's 0, that's 0. The only thing that remains is this, which is 2 times 8b, right? B is equal to 5. Wow. Sure is pretty. Let's see here, x equals to minus 2. That gives us 4 minus 24 plus 12, also known as minus 18, I think. And let's see here, minus 2, that's 0, that's 0. This is minus 2 times minus 4, 8c, 8, is that right? 8c? Really? Huh. I had such high hopes for this all being pretty. Oh well.
We have to add 2. We have to add 12, not 2. There, 4 minus 24 plus 12.
Oh, I knew something felt wrong. Thank you. And that makes it, all right, my faith in this problem being ridiculously easy is restored. Minus 12, minus 8, all right. So C is what? Can't let the students see fractions. No, no, no. Let's see here. So this is integral of minus 3 over x plus 5 over x minus 2 minus 1 over x plus 2 dx. And how do I know that? Just to be clear, because this kind of board work is dangerous, right? So what I'm doing is I'm taking these, putting it up in here, right? And then taking that and using, that's what makes that step, okay? Don't do this on your paper, please. On your paper, please do these things. Don't write that there. Write that down here, okay? Top to bottom work on your paper, please. My board space is limited. We got none of these things, you know, like you see at the reel said something. I don't know what now I'm going to have to edit this video. Great. I miss chalkboards. I can't deny it. You know, you watch these YouTube videos of people lecturing at like Harvard or Yale. Not that we have to be Harvard or Yale necessarily, but they've got chalkboards. And so many chalkboards, like chalkboard upon chalkboard upon chalkboard, and they go up into the thing somehow magically. It's amazing.
The engineers do that.
Chalkboards have engineers? I mean, other way around. Engineers have chalkboards here?
They'll make that.
I don't think we do.
We don't, but we can make them.
I was thinking the engineers can make it happen.
Oh.
That's a facilities.
Well, yeah. I guess that would be true. See, but in the interest of not, there's things I could respond and say at this point, but I really don't want to edit the video further, so I'm going to. Oh, I'm sorry. Why am I writing it? Now no one will be able to see it in line. Let me pick a color that actually shows up in my stupid video. Sorry, guys. I do like that green, but you know, my camera does not. Natural log S value of x plus, ooh, this blue is nice. So here I'm making U substitution, you know, and there you go. Any questions? Yes, Isaac, you have a question? Oh, okay. Let me try to find a different one. Let's see here. Did I assign number? Yeah, let's work number 19. There are various points in this course where we need to bound a function, right? Which means to put a function between two like numerical values. This idea of differentiating to find inequalities is useful for those kinds of problems. That's part of the reason I've worked that problem in here. It's because I know it's a skill set that you guys are rusty on, most of you. So it's important to kind of revisit that issue. Because graphing with calculus may have been underemphasized in your Calculus 1 course, depending on where you took it and stuff. All right, I'm trying to find a good one here. Maybe I should just go later. Come on, man. Where's the rest of the problems, dude? How many pages are in this calculus book? Why aren't there more problems? Great googly moogly. I feel cheated. Not cool, man. Number 20. Come on. There's 38 problems on partial fractions here. That's it? Gosh. X over 16 x to the 4th minus 1. Let's try to do this one. This is a good one, I think. Again, my apologies if this is in your actual homework. It seems very likely, given the small number of problems. But it's okay, we can work it together. It's still useful, right? So the question is, how does 16x to the 4th minus 1 factor? So notice that this is 4x squared, right? Squared minus 1. So the pattern is it's a difference of perfect squares, right? So this is 4x squared minus 1 times 4x squared plus 1. Now the first one factors further, right? This is 2x minus 1, 2x plus 1, 4x squared plus 1. Now, to make it fit the standard template that I did last time, we probably should like factor out, I don't know, fine. I don't know, see, I'm I'm not sure which way I want to go here. Let me show you the two different ways we can go, and you guys, you choose your own adventure. How about that? So here's the two ways we could go. We could do this. Like that. Or we could notice that 16x to the fourth minus 1 is 16 times x to the fourth minus 1/16, which is, by the way, 16 times x squared plus 1/4 times x minus 1/2 times x plus 1/2. Which would fit into my template, and then the partial fractions that you would do from that would be well, I'll do the x minus 1/2, you know. So you guys like the first one better? So it's up, I mean, we go either way. The advantage, so you guys are, you're repulsed by the fractions, but the fact of the matter is, when you get to the integration, these are easier. Right? Like when you integrate these, you got to actually think through u substitutions and such. I can go either way though. I'm trying to make you make an educated decision. All right, so votes for option 1. Okay, votes for option 2. All right, option 1 has it. I'm sorry, guys. Wait a minute, is there a football game this weekend? Oh, man. Football game and a hurricane. I don't like our chances next week. The good thing is, we're fresh out of techniques. Like, I think this is the last technique on test 1, right? If I look at the course planner, I think this is it for new material. If I'm not remembering wrong. So, we had a couple more days of examples. Then we got a math battle, we got a quiz, and then you got a test. Yeah.
For the bottom one there with the, were you taking derivatives of the?
No, that was just a label. If you'd like, I could put my advisor always use these things. Tilde, 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 tilde. There you go.
Sorry, I was confused.
No, I know. This is a thing, is since we sometimes use the prime for derivative, it gets sometimes frowned upon to use it for labels for other things, and yet people do. Okay, so we're option 1. Let's get to it. X. I mean, we can still integrate those things. It just requires a little bit more care. But when we get into the details of this, you're going to see that the fractions are unavoidable. Okay, so usual song and dance. Multiply by the denominator. I guess I gotta agree with you guys. It's more fun to not have fractions here. Fractions are a drag. It's here. I don't know. I can't make a decision here. That's here. Yeah. 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 Ay, ay, ay. All right. So we need to find A, B, C, and D, right? So I think you know what we're going to do. I don't know. I think this one I kind of want to try something a little bit different on, guys. So what I'm going to do here is I'm going to collect like terms. So what we're looking at is an what's the highest order thing in these products? How about this? What's the lowest order thing? Constants, right? So what are the constant terms? Like 1 times what? We've got an A. We got this A times 1, right? Is there any other constant term in here? 1 times 1 is it, right? Over here, 1 times b gives me plus b. Is there any way, I don't know, any other way to get a constant from here? No.
Shouldn't there be a subtraction sign?
Oh, yes, thank you. Oh, thank you. I'm glad you guys pointed that out now and not 2 minutes from now. Thank you so much. Yeah, that gives me minus b. Thank you. Over here, how can we get a constant? This minus 1 times this 1 looks like we're going to get a minus d. So collect together all the constant terms. And then x. How can we get x? Terms with an x. Multiply. Think about multiplying. So I got 2a, and 2a. Is there any other way to get an x from here? No. How about here? 2x times plus 2b, right? Anything else from here? No, x squared doesn't, all right. Let's see here, these guys, what can I, it might be good to be safe. This is 4x squared what? Minus 1, right? That's what that is. So when I think about multiplying this times that, I can only get what? Well, careful. C, but what? I mean, C was right. Minus C, though. Maybe you guys said it. I just didn't hear it. I think that's it. Is that it? And x squared, what do we have for x squared? Looks like we got a 4a. Here, what do I got? I've got minus 4b. And what else do I got? Over here, plus 4d, right?
Why is there minus 4b?
It's because it's minus 1 times 4x squared times b. Okay, good question. And then plus x cubed. What do we got in the world? What do we got in the world of x cubes? We got 2 times 4, which is 8a. Yeah, anything else? Over here, looks like we got plus 8b. All right. And then how about here? Plus 8c, right? Now, this may or may not be the best way to solve this problem, but I wanted to make sure I illustrate this technique for you guys, which is that, yeah. Oh, yeah, you're right. Yeah, I'm sorry. I somehow invented another 2. Thank you. Very good, guys. So I wanted to illustrate this technique because this is another, like we've been plugging in numbers to do the algebra, right? But the other important trick to know about is to just collect like coefficients of x, and then you can just equate coefficients, because when we have a polynomial equation, right? This has to be true if the coefficients match on each side. So I can equate coefficients. So equating coefficients, what's that give me? So let's start with 1. There is no constant over here, so we get 0 is equal to a minus b minus d. How about x? We got 1x, right? And that's equal to 2a plus 2b minus c. We got x squared. We have 0 on the left-hand side. Over there, we've got 4a minus 4b plus 4d. X cubed. What do we got? 0 on the left-hand side. And over there, we've got 8a plus 8b plus 4c. I mean, this sort of thing can happen. We've been very fortunate so far in our examples in that the algebra has been mostly uncoupled. But this algebra is coupled in the sense that we have 4 equations, 4 unknowns, and almost every equation involves more than 2 variables, right? I mean, like there's a lot of, you could say they're kind of intertwangled or something. Now, the question is, how do you solve 4 equations and 4 unknowns? Do you guys know? Yeah.
Can't you like multiply the 1 by like 2 and like cancel something out? Something like that?
So you're thinking about like combining equations or something. I mean, elimination is usually what you guys are taught before this, right? You try to eliminate variables until you're down to just 1 equation and 1 unknown, and then kind of figure your way back up, right? That's one way. if it's on homework and it's not on a test where so on a test you don't have a calculator that can do this, right? But outside of a test environment, the other thing you can do is calculate the reduced row echelon form of the following matrix. What's that? Oh, okay. Was it something I said? Just being here? Oh, I forgot. I didn't realize where the laugh was coming from. I see. I thought it was when I didn't realize you're here, Audrey. I'm sorry. I'm misinterpreting the laugh. Let's hear. 4. And we got an 8, 4, 0, and 0, 1, 0, 0. So this is the reduced row echelon form. This is, if you have a Texas Instrument calculator, this is built in, right? There's a website that you can plug the numbers into, and it will do this calculation for you. I can show you in a minute. Of course, the other thing you could do is if you put these equations into Wolfram Alpha, right, and like list them, the first comma, the second comma, the third comma, the fourth, Wolfram Alpha will find the solution as well. There's any number of ways to get yourself help on these kinds of systems. But you do need to find a way to solve them by yourself as well. I mean, because you don't always have technology to help you out here. So, but with technology, this is how I do it. I would plug this matrix into, appropriate either website or calculator, and that would do it for me. But here I'm kind of without that, right? So should I face these equations, or should I try to say, is there something easier I could do here? Because we could be here solving these equations the next 10 minutes. Like, that wouldn't be that productive for us, would it? No. What would something we could do that would get us an easy equation and let us kind of go forward from here? You can mix methods, right? There are 2 nice equations that come for this problem because it's got a root. It's got 2 roots, right? What are the roots? We can evaluate at x equals 2 plus or minus 1/2, right? What happens when you plug in, going back up to, let me call it star, what happens when you plug in plus or minus 1/2 into star? We get tons of zeros, right? So let's put x equals to 1/2. What's that give us? We get 1/2, right? Equal to, what's 1/2 times 2 is 1. So this is 2a times what? This thing, right? What's 1/2 squared? Oh man, that's kind of nice. That's 2 also, isn't it? Because that's 1 plus 1 is 2, yeah? But that's 0, and this is also 0. So this is a really nice equation because this says a is what? Right? A is 1/8. If we plug in x equals minus 1/2, what does it give us? So now the first and the third term vanish, the middle term survives. We put minus 1/2 times 2, we get minus 1, which is minus 2, right? We get b times minus 2 times 2, because, see, that's still 1 plus 1, which is 4, when we plug in x equals to minus 1/2 there. So what's that make b? B is 1/8 as well, right? So this is actually how I calculate. I use a mixture of these 2 methods. I use whatever zeros I have, because those give me nice equations. But they don't always give me enough equations, right? Because I've got 4 unknowns, but the zeros just give me 2 equations. So what do? Yeah, I use some of these. So you don't have to write all of these out to use them, right? It would suffice to just pick on 1 or 2 that's interesting. So I kind of like, I like that first one's pretty awesome. Because the first one says what? D is equal to? A minus B. Oh, 0. Thanks. AKA 0. Okay. Thank you. You guys are way ahead of me. Excellent. And how about the X one? The third one? Yeah, I think that the third one's kind of, these are, oh look, these are the same equation, right? Cool. The second one, you think? So the second one I can solve for C, right? C is equal to 2A plus 2B minus 1, right? Also known as 2/8 plus 2/8 minus 1, aka a half minus 1, also known as minus 1/2. Minus 1/2 is equal to C. Yeah?
So you got the like plus or minus 1/2 from the 2x plus 1, just like equals 0.
Right. So when I see 2x plus 1 set it equal to 0, that says that x is equal to minus 1/2. Right? And 2x minus 1 equals to 0. If I do the algebra, it gives me x is equal to 1/2.
Okay,
So
why did you do the negative 1/2 for b instead for a? And the 1/2
1/2 for a.
yeah, you said that the a stuff equal to 1/2 instead of negative 1/2. Or is it, do you go back to, sorry, like is it because it's a over 2x minus 1? And so that would be, okay.
It's there's a lot of things going on. Like it starts out with 2x minus 1, right?
Right.
But then when we multiply by the denominator, it's got everything except for 2x minus 1.
Right.
So that puts 2x minus 1 over here and over here, which is why when we plug in a half, this is gone and that's gone, but that term remains. So there's this sort of like duality going on, yeah.
Can we, my question is, why couldn't we do this off the rep, solve for 2 of the unknowns, then use that to solve for the third?
Well, if we actually calculate the Rudistor echelon form, what it would do for us is it would straight up give us this matrix. A was 1/8. Now, depending on what you're using, it may or may not give you actual exact fractions. It might give you decimals, but it would give you this. And then you look at this, and if you understand what that means, this means that you can add and switch equations, multiply them by numbers, do allowed operations to equations. And this is an equivalent system of equations. This system of equations is the stupid system that says A is 1/8, B is equal to 1/8, C is equal to minus 1/2, D is equal to 0. I mean, this, you guys will learn this in Math 221 if you're supposed to take that, or Math 321. But some of you have seen it in high school, I hope, yeah? Or college algebra. I mean, I saw this in college algebra, but whatever. Okay. Oh, let's finish the problem. So finally, kind of anticlimactic. I mean, most of the trouble here is algebra, right? So we just figured out that the integral of, what was it, x over 16x to the 4th minus 1 dx can be, we can trade this for the integral of, what is it? What was a 1/8, right? 1/8 over 2x minus 1 plus 1/8 over 2x plus 1 plus, let's see, minus 1/2 x divided by, what was it, 4x squared plus 1? Man, this book is too kind. Sometimes. So if we make w, let's say let's make u1 equal to 2x minus 1. Let's make u2 equal to 2x plus 1. Let's make u3 equal to 4x squared plus 1. We need to make 3 separate, but kind of similar u substitutions here. What's du1 then? I'm sorry, 2 dx, right? What's du2? 2 dx. What's du3? 8x dx, yes. So with those in mind, we have the integral of du1 over 16u1 plus the integral of du2 over 16u2 minus 1 over 16, the integral of du3 over u3. If I haven't made an arithmetic mistake, I mean, x dx is 1/8 du3, and then that 1/8 and the minus 1/2 conspires to give me a minus 1/16, and there you go. So we get, I'll factor out that 1/16 since it's everywhere. We got natural log the absolute value of u1, which is 2x minus 1, plus the natural log the absolute value of 2x plus 1, minus the natural log the absolute value of 4x squared plus 1, plus a constant. Feared, which for what it's worth is 1/16 the natural log the absolute value of 4x squared minus 1 over 4x squared plus 1. Cool. I would still give partial credit, perhaps full credit for the without the natural log simplification, but it would probably earn a bonus point if said student was to make the log combination at the end, yes. I'm anticipating a question. But so sum is product. This times that gives me 4x squared minus 1.
Oh,
And then that's minus, so it gets to be division in the log using properties of logs. Yeah. I've not told you guys much about Crazy Paul. There's reasons for his being called Crazy Paul. My other friend is also named Paul. I call him Somber Paul. It's appropriate. But one of Somber Paul's pet peeves was graders who didn't know laws of logarithms. Like, we do a physics problem, junior level physics, and he come to this answer, and then he used the laws of logarithms to simplify it. And then the grader took off points. Why? Because the stupid answer key hadn't used laws of logarithms to simplify it. Paul gets so angry. Grader, not knowing laws of logarithms. Next time he turned in, he would code messages for the grader in caps, like mostly lowercase letters. But if you look back, there's a series of capitalized letters that say you're stupid. Like, this is sort of passive aggressive action that Paul would take against the grader. Gave me joy. He also feigned arrogance, which was fun. Like, he would pretend he wasn't actually arrogant, as he would say, how could I learn things if I'm arrogant? I mean, that right there says a lot. But he knew it. Other people thought he was arrogant, and so he would play the part sometimes, which was fun. Crazy Paul, on the other hand's principal mode of operation was to offer motorcycle rides to all the ladies. And if you called him on it, then he would offer you one, thus resulting in awkwardness, yes.
whatever happened?
Oh, the story of Crazy Paul is a long story. I'm not sure we have time at the moment.
But throughout the semester, you'll...
I will tell you more about Crazy Paul. Yeah, stay tuned. So guys, I don't want to hurry and do another partial fractions example here. Do you guys have any questions about like the general idea of the method, where we're going, anything? Yeah.
Yeah, so, like, I'm confused why we, like, do you want us to take a matrix, or?
I'm just saying it's something that you should know about, because you might face in any of your classes, technical classes going forward, a system of linear equations. So this is a technique to solve them. You can put it in a matrix and do row reduction.
If you know that, life gets easier.
Now, this you can't do on a test because I don't give you access to a computer, right? But in the wild world of homework, if you wanted to check your answer or something, this is something you could do. Let me show you that, actually.
So you can't use calculators on tests?
Not that can do that, no. You're allowed a scientific non-graphing calculator on the test. We are not done yet. I can see what the problem is. Ha ha! 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 Now you're gonna get it. It's a good thing I didn't hit his head. It would hurt him. I would let the one go out under the door. You'll notice the Teenage Mutant Ninja Turtle socks if you look carefully. Whoa! Oh no! Oh no. Duck. Watch out, guys. He's about to send a barrage.
I broke a pen.
Oh no.
I broke.
Oh, that's okay. So guys, on my webpage, if you go down here, under links that websites do math for you, number 3. If you go here, transforming matrix to reduced echelon form like that, you can actually. Oops. Well, anyway, this isn't the same as your problem, but here I'll do one. Since we're out of time, I'll just make up one. And it will actually walk you through how to do row reductions. You know what that is? And it'll show you that the answer to the system of equations corresponding that I started with is A equals to minus 400 to 157, B is equal to that, and C is equal to that. This is super useful when you get to like math 221, for example, to check your homework. Anyway, I digress. I think you have to go back to your mom. Yeah. Say bye.
No.
No, you're not going to say bye?
No.
Oh. Have a good weekend, guys.
One more thingy.
Oh no.
Ah!
You, Daddy.
You got me. All right, Isaac, get your stuff. We got to go, man.